All right, ladies and gentlemen, welcome back. Just a little additional video for you. We're going to talk about an application problem involving the volume of the cone. I'm going to move my video here a little bit so we can see. So let's go ahead and let's read this problem together and kind of see what they want us to do. So Zeonia has two choices of paint to buy. The new paint that comes in a fancy cone-shaped container is $14.95, and the Home Depot brand comes in a cylinder for $21.85. Now, if you did not know anything about math and you just saw that, you'd immediately say, hey, well, it sounds like the fancy cone shape is better. It's $14.95. The other one's $20.85. It sounds cheaper to me. But really what we need to see is how much the price is per unit of what we're buying here. So it's going to ask us if the containers have the following dimension, which one is a better buy. So we're going to figure that out by basically figuring out, well, what is the cost per unit of paint that I'm getting, and then we'll use that to figure out which one's cheaper. Well, how do we do that? Well, the first thing we're going to need to do is figure out the volume. Basically, figure out how much paint is in each of these containers. So I'll go ahead and take each one and find their volume. So let's go ahead and let's start with the cylinder. The cylinder is going to be pi r squared h. So we're going to go ahead and we'll plug in these numbers. So our volume or our radius is going to be 4. So we're going to we'll use 3.14 to estimate pi. We'll plug in 4 for r, and we'll go ahead and plug in 13 for a height. And now we'll go ahead and take our calculator here. So everybody should have the calculator. Go ahead and plug that in and see what the volume is of the cylinder. And when I go ahead and I plug this in, I'm getting that it's 653.12. I'm going to go ahead and round that to 653. And that's my approximate volume of the cylinder. Now for the cone, I'm going to go ahead and do the same sort of calculation, but this time because it's a cone, I'm going to use the cone formula, which if you remember is pi r squared h over 3. Now, I need to be careful when I go to do this, and again, you saw this a lot with the cylinder, but this 8 inches is not talking about my radius, it's actually talking about my diameter. So I need to cut that in half, and so my radius is actually going to be 4. So I'm going to have 3.14 times 4 squared times 13, and then we're going to go ahead and we're going to divide that by 3. All right, and I'm going to go ahead again, take my calculator here, go ahead and put that in and calculate it. And when I do that, I'm going to get 217.7, which I'm going to round to about 218. Okay, Mr. Guy, well, that's well and good. We found the volume, but what does it have to do with which one's a better price? Well, we want to go ahead and calculate what the cost per unit is. And to do that, what we're going to do is we're going to take the cost of the entire thing and divide it by that volume that we found, right? Here's the price of the whole thing divided by how much of that thing we have, and we can figure out the cost per unit of what we're looking at. So in this case, I'm going to go ahead, I'm going to take a look at the cylinder here, and I'm going to take the price of the cylinder, which was $21.85, and I'm going to divide that $21.85 by the 653 that I found and see what the cost per unit is. This is per cubic inch is basically what we're finding. And if I go ahead and do that division, let's see, 21.85 divided by 653, I'm going to get that the cost is about 3 cents per inch cubed. Okay, or if you did in your calculator, you probably got 0.03 as your answer here. Okay, so you got 0.03, which is about 3 cents per cubic inch, 0.3 cents, okay? Now let's go ahead and do this calculation over here. So for this one, we have 218, and we can see the price of this is $14.95, right? $14.95. So we're going to do for this one, so this was our unit price here. We're going to go ahead and do 218, and we're going to do the $14.95 divided by that 218, and that's going to give us this unit price that we're looking for. So $14.95, we're going to divide that by 218, and I'm going to get that this is actually about 6 cents per cubic inch. Okay, so you got 0.06, which is about 6 cents per cubic inch. Now, looking at that, which one is the better deal? Well, even though the cone is cheaper, if I'm thinking about the actual amount of paint that I'm getting, the cylinder actually has a cheaper cost per unit that I'm looking at. So the cone is actually cheaper per like piece of paint than the cylinder's cheaper per piece of paint than the cone is. You actually can see this, and you can actually ask your parents about this when they go shopping at the grocery store. You'll actually see this all the time, where if you buy these larger items, sometimes they might be more expensive, but they're cheaper per thing you're buying. So, for example, I know everybody's trying to buy toilet paper right now. If you buy a thing of 6 toilet paper, the cost per toilet paper might be more than if you bought a thing that had 30 toilet paper in it. Or, for example, when you buy like macaroni and cheese, if you get a really big box of macaroni and cheese, it might be cheaper per noodle, which means that as long as you're going to eat it all, that actually is a better bargain for you than getting the smaller one. And that's what we're seeing here. So, in terms of which one's a better buy, I mean, I would say that based off the unit prices here, it definitely is going to be the cylinder would be the better buy. That would be the one that I would buy. Cost me less per unit of what I'm looking for. Thank you for watching this application. As you're going to see when you go to do your independent practice, you're going to see a problem like this. So make sure you pay attention to what we did here and that you can go ahead and do that when you're asked to leave.